Hi guys, welcome to chapter 7. Today we're going to talk about vitamins, both fat soluble and water soluble. Um, just a little bit of a disclaimer before we get started. My allergies have been really bad today, so if I sound stuffed up or if you have difficulty hearing or understanding me, please ask me a question. Feel free to email me a question or ask me on Thursday. And again, I I apologize that I'm so stuffed up today, but I wanted to get this recorded so that I could get it posted. Introduction: vitamins are organic. That means that they contain carbon. Um, they are considered micronutrients if you remember back from our very first lecture talking about macronutrients and micronutrients. We talked about macronutrients already, about carbohydrates and protein and fat, and now we're talking about micronutrients. And vitamins fall under that category. Vitamins are essential. They are nutrients that we have to get from our diet because our bodies are unable to make them ourselves. They're not energy yielding, which means they don't provide calories, though certainly the foods that they are in might contain calories. The vitamins themselves don't contain any calories. And you'll see as we go through that vitamins can be classified as either water soluble or fat soluble, which is a pretty important distinction as it makes a difference in how they are absorbed and stored in your body. So here's a little breakdown of water versus fat soluble vitamins. So you see vitamins at the top, water soluble goes to the left, fat soluble to the right. There are two main groups of water soluble vitamins. There's B vitamins and vitamin C. Um, so vitamin C is vitamin C. But B vitamins, there are several that we're going to talk about. Thiamine, which is also B1, riboflavin, which is known as B2, niacin, which is B3, biotin, pantothenic acid, vitamin B6, folate, and vitamin B12. So all of those are classified as water soluble. Then for fat soluble vitamins, we have vitamin A, vitamin D, vitamin E, and vitamin K. And we'll talk more about each of those in much more detail as we go through this chapter. Vitamins in our food. Almost all foods contain some vitamins. The amount of a vitamin in a food depends on the amount that's naturally present in the food, but also what's added to it, how the food is processed, prepared, and stored. So it's not enough that a food contains a particular amount of vitamin because your body may not absorb it effectively. Maybe how the food is stored might have affected if the vitamin was broken down from its original state. So there's lots of things that can affect how many vitamins we actually get from a particular food. Vitamins in food groups. So certainly this isn't an exhaustive list. A lot of these vitamins can be found in multiple food groups. And there's always exceptions to these, but generally, this slide looks at the MyPlate categories, and under those categories, which vitamins are most typical in each of those food groups. So you can go ahead and take a look at that. I believe this is also in your text. But yeah, lots of really great information here. Fortification. This is something we talked about already, the difference between fortification and enrichment. We know that fortification adds nutrients to foods. It could be either government mandated or voluntary, and it works to prevent deficiencies that lead to diseases. but it can also cause toxicity, where fortification might lead to overconsumption of a particular nutrient. And this graph is showing us one example, and this is with enrichment of flour. And you'll see on the y-axis there the number of deaths from pellagra. Now, pellagra is a deficiency of niacin or vitamin B3. So this graph goes all the way back to 1938, when you can see there was a very high rate of death from pellagra or niacin deficiency. At that time, to combat pellagra, some flour manufacturers began to voluntarily enrich their product with niacin or vitamin B3. And you'll notice after that voluntary enrichment that the incidence of pellagra dropped steadily. Then about 1943, some states passed mandatory enrichment of flour products. And you'll notice again that the number of deaths from pellagra continued to decline, followed by mandatory enrichment in nearly half of the states in 1948, where we see that last steep decline of pellagra rates down to almost no incidence of vitamin B3 deficiency in 1954. So this is an example of, there was this vitamin deficiency that was a huge problem. Some manufacturers took notice, began enriching their products on their own, and once that enrichment occurred, we really saw a decrease. So the government kind of caught on to that and started mandating that enrichment was done, which drastically improved the health of the country. Vitamin loss. Because they are organic, vitamins can be destroyed and no longer perform their duties. Vitamins can be damaged by exposure to light or oxygen, washed away during preparation, or destroyed by cooking. Vitamins must be handled with care during storage and cooking. So this is like what I mentioned just a couple slides ago, that just because a particular food contains a certain amount of vitamins doesn't mean that those vitamins are actually going to make it into your body where they can be used. There's certainly lots of places along the way where they can be damaged or their absorption can be affected. So this is right from your text, Table 7.1, tips for preserving the vitamins in your food. Store food away from heat and light and eat it soon after purchasing it. Cut fruits and vegetables as close as possible to the time when they will be cooked or served. Don't soak vegetables. Cook vegetables with as little water as possible by microwaving, pressure cooking, roasting, grilling, stir frying, or baking rather than boiling them. You'll notice a lot of mention of water here, sometimes being submerged in water for a long period of time or cooking in large amounts of water can cause the vitamins to actually leach out of the vegetables. If foods are cooked in water, use the cooking water to make soups and sauces so that you can retrieve some of those nutrients that are lost in the water. And don't rinse rice before cooking in order to avoid washing away water-soluble vitamins. Vitamin bioavailability. About 40 to 90% of the vitamins in food are actually absorbed by your body. Bioavailability is a term that means the extent to which the body can absorb and use a nutrient. Fat-soluble vitamins are absorbed along with dietary fat, where absorption depends on fat consumption. So if somebody is following a very strict diet that drastically limits the consumption of dietary fat, then that person may also experience a deficiency in fat-soluble vitamins. So just something to keep in mind as we're going through the different types of vitamins and talking about where it is that they're found. Bioavailability depends on many factors. So again, this is, the nutrients, the vitamins that are in a food. What are some things that can affect your body's ability to actually absorb the nutrients in a food? So efficiency of digestion and time of transit through the GI tract. Um, if you have diarrhea or maybe another GI problem and food is passing through your digestive system way too fast, your body may not actually have enough time to extract all of the vitamins from that food. Also, previous nutrient intake and nutrition status. Other foods consumed at the same time can either increase or decrease the effectiveness of absorption for a particular nutrient. Method of food preparation and source of the nutrient. Is it synthetic? Is it coming from a fortified food? Or is it just naturally occurring? Provitamins or precursors. Some vitamins are available from foods in inactive forms known as precursors or provitamins. Once inside the body, the provitamin is then converted to an active form of the vitamin. So this is sort of just saying that, we'll talk about specific examples, but this is just saying that sometimes the vitamin, like the versions of the vitamin that are in the food, are not always turned on. They're not always, even if you absorb them, they're not always in a state that your body can use. And so in those instances, your body has ways of turning them on and activating those vitamins so that they can be used once they're absorbed into your body. Vitamin functions. Two major functions of vitamins, coenzymes. Vitamins can work as coenzymes, which are organic, non-protein substances that bind to enzymes to promote its activity. So it's basically just like a little helper for an enzyme to help complete a chemical reaction in the body. Second, an antioxidant, probably a word that you've heard a lot. People are marketing their food products, but maybe not something that you've heard about in great detail. An antioxidant specifically is a substance that decreases the adverse effects of reactive molecules on normal physiological function. So this might be kind of small for you, but it is in your text, so feel free to look it up. It's just showing us a visual breakdown of what it is that a coenzyme does. So in the at the top of this picture, I guess I'll use my little arrow here. This blue shape here is an incomplete enzyme. The vitamin here is the purple and this chemical group is the yellow. So in this instance, you eat a food, you absorb this purple vitamin. Once you absorb it into your body, this chemical group, which is already in your body, binds to that vitamin. You have this incomplete enzyme here that works to carry out a particular chemical reaction, but in its normal state in your body is incomplete. So once you absorb this vitamin and it binds with this chemical group, it becomes a functional coenzyme. So this is that helper that we just talked about that helps the enzyme to achieve its function. So the functional coenzyme, which is mostly made up of the vitamin, binds to the incomplete enzyme. Now you'll see here once the incomplete enzyme is bonded to the coenzyme, it becomes activated. And then you have, in this instance, this shape is complete, which allows the enzyme to bind to the molecule, this little oval shape here. And in this particular process, the molecule or the enzyme is helping the molecule to pick up this chemical group. So now because of the presence of the vitamin, the molecule is able to sit in this binding site, pick up that chemical group, and go about its business in the rest of your body, and then the enzyme and vitamin disconnect and continue going about their business. But without the presence of this vitamin, this chemical reaction would not be able to take place because the molecule wouldn't be able to bond to just this little half circle of an incomplete enzyme. Free radicals and antioxidants. So antioxidant, this is the second function that we really talked about for vitamins. So this down here probably looks familiar. It's just a little figure of DNA, and these sort of yellow and green, they look sort of like comets coming in here. These are free radicals. So we'll talk more about free radicals and where they come from, but ultimately when they are in your body, they can sort of storm in here and bust into your DNA, causing damage. But antioxidants work to neutralize free radicals so they no longer damage molecules like DNA. So in this picture, we see this yellow free radical, looks kind of intense, flying in here. And then over here we have vitamin C, and vitamin C is an antioxidant. We'll talk about it and other antioxidants later this chapter. But you'll notice the vitamin C breaks up this free radical and neutralizes it, so that now it's just sort of this green circle that looks a little bit less threatening and isn't able to come in and damage your DNA. So that's sort of a more detailed explanation of what it is an antioxidant does. Meeting vitamin needs. We talked about DRIs and about the overall group of DRIs and how they include several other recommendations, including the RDA, AI, and UL. Some vitamins you're going to find use different measurements for vitamin needs. Some might have a UL, some might not, but we'll go over each of them individually as we go through. Vitamin A and C amounts are required on food labels as % daily values. Not all. Some nutrition labels, I'm sure you've noticed, have multiple vitamins and minerals listed there. That is completely voluntary if they choose to include those. But all nutrition facts labels are required to have A and C, so you should at least see those listed. And this picture is just showing you where those would be. This is an example of orange juice. Nutrition facts labels, the percentage given, of course, is based on a 2,000 calorie diet. That's just kind of a average figure, but certainly calorie needs are going to vary based on the individual. And in this particular instance, the orange juice company, decided to list other nutrients like calcium, riboflavin, vitamin B6, magnesium, lots of other good stuff. All right, so now we're going to start talking about water-soluble vitamins. So we're going to talk about all the water-soluble vitamins first in greater detail, and then we'll talk about fat-soluble vitamins. So first up, a little bit of an introduction here. If you remember from that chart, water-soluble vitamins include B vitamins and vitamin C. B vitamins are involved in converting the energy in carbohydrate, fat, and protein into ATP. If you remember, ATP is energy that's able to be used by cells. And vitamin C is needed to make connective tissue and acts as an antioxidant. Water-soluble vitamins are not stored, therefore they need to be consumed regularly. They're excreted in the urine, except for folate and B12, and high doses of them can still be toxic. So, water-soluble vitamins are not stored. This is really important. So, if you are consuming, I guess probably the most popular example would be like an energy drink. If you ever looked at the nutrition facts label on an energy drink, a lot of times it'll list all kinds of B vitamins, and it has them in like 200, 250%, 300%. And you might think, wow, that's awesome. 3 times as much. But water soluble vitamins aren't stored in your body. So once your body has all of the B vitamins or vitamin C that it needs, you're just going to excrete that out in your urine. So, the orange juice example we had a little bit ago had 120% of your vitamin C. Awesome. But that extra 20% is just going to be, excreted in your urine. So, as far as making sure that you get extra, making sure that you get a lot of water soluble vitamins, it's kind of a waste of money because you're just going to pee it all out. However, high doses can still be toxic. So even though water soluble vitamins don't build up in your body and they're excreted, if too many water soluble vitamins were consumed all at one time before they had the opportunity to be excreted, it could still be toxic to your body. But we will talk about each of them individually in just a second. So we're going to start with the B vitamins. Thiamine is also known as vitamin B1, but you will see it listed as thiamine on a nutrition facts label. It's good to remember it as vitamin B1 simply because, otherwise you might forget that it is actually one of the B vitamins. Thiamine is a coenzyme needed for glucose breakdown to provide energy. So if you remember that coenzyme chart, thiamine is going to, work together with enzymes in your body to take glucose and break it down into a form that can be used as energy for your cells. It's also needed for metabolism of other sugars, certain amino acids, and synthesis of ribose, which is a component of RNA. Thiamine is also important for nerve function because glucose is the energy source for your nerve cells and needed for synthesis of neurotransmitters, which are the chemical signals that move from one neuron to another. And this is just showing you, so we have this glucose molecule here. Glucose turns into pyruvate, and then because of the presence of thiamine, it's able to change into acetyl-CoA, which can either participate in neurotransmitter synthesis, or the creation of ATP for energy. This isn't anything that you're going to need to memorize, or know what pyruvate or acetyl-CoA is. It's just kind of giving you a little bit more detail about how the process of glucose turning into ATP, how that takes place, and where thiamine affects that process. The RDA for thiamine in men, it's 1.2 milligrams per day, and in women, it's 1.1 milligrams per day. We're going to go over the RDA values for all these different vitamins, but they're not numbers that you're going to have to memorize for the tests, but they are good to know for your own personal reference and good to compare one vitamin to another. Sources of thiamine or vitamin B1 include the bran layer of whole grains, can also be found in enriched grains, pork, legumes, and seeds. Two different thiamine deficiencies. One is called beriberi, which is characterized by weakness, nerve degeneration, and heart changes. Also, Wernicke-Korsakoff syndrome, which is found in alcoholics. People that drink a lot of alcohol, that consumption of alcohol in high amounts will decrease your body's ability to absorb thiamine. So in this instance, a person may be consuming foods that are high in thiamine, but because of their increased alcohol consumption, they're unable to absorb it. So Wernicke-Korsakoff syndrome is characterized by mental confusion, psychosis, memory disturbances, and coma. And there are no reported effects for excess of vitamin B1. This chart's in your book. I'm not going to go over it in super detail, but you'll notice the colors correspond to the different sections on MyPlate, and showing you the RDA for women and men down at the right hand side of the chart, and where different foods fall in their in the amount of thiamine or vitamin B1 that they contain. All right, riboflavin. So riboflavin is vitamin B2, but you'll see riboflavin listed on Nutrition Facts label. Good to remember though that it is one of the B vitamins. Riboflavin forms two active coenzymes that act as electron carriers, functioning in reactions needed to produce ATP from carbohydrates, fats, and proteins. Riboflavin is also involved in converting folate, niacin, vitamin B6, and vitamin K into their active forms. So what this means is if you're consuming foods that contain folate, niacin, vitamin B6, and vitamin K, you're eating those foods, your body's absorbing those vitamins, that you are likely absorbing them in their inactive forms. So even if you are taking them in, that doesn't mean that your body is able to use them. The presence of riboflavin, in addition to these vitamins, allows these vitamins to be turned on into their active forms so that they can carry out the functions that they need to in your body. But without sufficient riboflavin, your body would absorb them, but not be able to really use them. The RDAs for riboflavin in men, 1.3 milligrams per day, in women, 1.1 milligrams per day. Sources of riboflavin include dairy products, liver, red meat, poultry, fish, whole grains, enriched grains, asparagus, broccoli, mushrooms, and leafy greens. Deficiencies of riboflavin can lead to injuries, healing poorly, cracking of lips and corners of your mouth, sensitivity to light, eye burning, tearing, and itching, skin flaking around nose, eyebrows, and earlobes. There are no reported effects of riboflavin excess. However, high levels of riboflavin intake can turn your urine a bright fluorescent yellow. So that would be a little indicator of high riboflavin intake. Ultraviolet light does impact riboflavin in products. So this example is showing you milk. Milk that's exposed to UV light. That UV light can cause the riboflavin in the milk to break down and not, be useful for the body anymore. We keep milk in the refrigerator, so there's, no UV light in there. But it's one of the reasons why you might see milk in cartons or opaque containers, just to additionally limit the amount of UV light that comes in contact with the milk. And again, from your text, showing you sources of riboflavin across the different food groups. Niacin functions. So again, niacin is a B vitamin. You'll see it listed as niacin on nutrition labels, but it is vitamin B3. Niacin works as a coenzyme in glucose metabolism and synthesis of fatty acids and cholesterol. In men, the RDA for niacin is 16 milligrams per day, and in women, 14 milligrams per day. Sources include meats, fish, peanuts, whole and enriched grains, legumes, wheat bran, and it can also be synthesized from the essential amino acid tryptophan. Deficiencies of niacin include pellagra, which is the deficiency that we talked about in that graph earlier. Pellagra can be characterized by fatigue, decreased appetite, indigestion, and the 4Ds. The 4Ds refer to dermatitis, diarrhea, dementia, and death. And with each of these, the deficiency is more and more severe. So dermatitis is going to be issues affecting the skin. That's a more mild form of pellagra. But then as a niacin deficiency becomes more and more severe, it could lead to diarrhea. Ongoing deficiency could lead to dementia, and of course, in the most serious of circumstances, could lead to death. For excess niacin consumption, no reported effects from food, but supplements can be toxic, causing skin flushing and rash, tingling in hands and feet, nausea, vomiting, diarrhea, high blood sugar levels, liver function abnormalities, or blurred vision. And niacin sources, you'll see really high sources of niacin in the protein food group, and some smaller amounts in whole grain sources. Biotin functions. Biotin is another B vitamin, but again, you'll see it listed as biotin on a nutrition facts label. It is a coenzyme in energy production and glucose synthesis. It's important in fatty acid and amino acid metabolism. The AI for biotin is 30 micrograms per day. So you'll notice biotin is an example of a vitamin that doesn't have a specific RDA for men and women. For biotin, there's just a set AI for the whole population, and that's 30 micrograms per day. Sources of biotin include cooked eggs, liver, yogurt, nuts. It can also be synthesized by gastrointestinal bacteria. And in general, fruit and meat are poor sources of biotin. Deficiency of biotin is often seen with malabsorption or malnutrition, can be seen with certain medications that are taken for long periods of time, eating raw eggs. It can cause nausea, thinning hair, loss of hair color, tingling in hands and feet, red skin rash, depression, lethargy, and hallucinations. There have been no reported effects of biotin excess. Pantothenic acid, another B vitamin. We're still talking about B vitamins. All of these are water soluble. Pantothenic acid is an important part of coenzyme A, or CoA, which is needed for the breakdown of carbohydrates, fatty acids, and amino acids. It's also important for the modification of proteins, synthesis of neurotransmitters, steroid hormones, and hemoglobin. We talked a little bit about hemoglobin back when we talked about proteins, but hemoglobin is a part of your red blood cells and is specifically responsible for carrying oxygen from your lungs, in your blood through your circulatory system out to other parts of your body. So it's super, super important. Pantothenic acid is needed to form a molecule which is essential for cholesterol and fatty acid synthesis. Excuse me. And again, with pantothenic acid, we have an AI for our DRI, right? No RDAs for this one. The AI for pantothenic acid is 5 milligrams per day. Sources of pantothenic acid include meat, whole grains, legumes, meat, and lesser amounts in milk, vegetables, and fruits. But it is widely distributed in, across food groups, which makes deficiency rare because there are so many different food sources of pantothenic acid. Despite it being in a lot of different foods, there are no reported effects of excess for pantothenic acid. vitamin B6 functions. So vitamin B6 will often just be listed as vitamin B6. It is important for a number of things. Amino acid and protein metabolism, synthesis of non-essential amino acids, neurotransmitters, and hemoglobin. Again, that protein in blood that's responsible for carrying oxygen throughout your body. Vitamin B6 allows for tryptophan, which is an amino acid, to be converted into niacin, another one of the B vitamins. And vitamin B6 is also essential for glycogen breakdown. It comes in 3 different forms: pyridoxal, pyridoxine, and pyridoxamine. These are converted into the active coenzyme pyridoxal phosphate, which is needed for the activity of over 100 enzymes in carbohydrate, fat, and protein metabolism. So in short, vitamin B6 is hugely important as a coenzyme, and without it, your body's metabolism of carbohydrates, fats, and proteins, the macronutrients, would not be able to take place. Vitamin B6, the RDA for men and women ages 19 to 50 is 1.3 milligrams per day. Sources of vitamin B6 include chicken, fish, pork, organ meats, whole grains, legumes, sunflower seeds, bananas, broccoli, spinach, some fortified cereals, though refined grains are not good sources. Deficiency for vitamin B6 can lead to poor growth, skin lesions, decreased immunity, anemia, and neurological symptoms. There are no reported effects of excess from food, but supplements, receiving too much vitamin B6 from supplements, can be toxic and can cause severe nerve impairment. So sources of vitamin B6, you'll see a lot of protein sources being the highest in vitamin B6, also brown rice and whole wheat bread. A little bit in fruits and vegetables, but not too much. Folate or folic acid functions. Folate coenzymes are needed for DNA synthesis, especially needed in rapidly dividing tissues and some amino acid metabolism. It's important in early pregnancy for neural tube formation, which develops into the brain and spinal cord. Folate is also important for preventing homocysteine levels from rising, which ultimately prevents heart disease. Folate or folic acid, the RDA for men and women, is 400 micrograms per day. Sources of folate include enriched grains, leafy greens, asparagus, legumes, nuts, oranges, liver, and yeast. Deficiency of folate can lead to neural tube defects, including spina bifida and anencephaly, macrocytic or megaloblastic anemia, poor growth, nerve development and function problems, diarrhea, tongue inflammation, and increased risk of heart disease and some cancers. Excess folate, some concerns that excess will prevent folate deficiency symptoms and mask B12 deficiencies. So this is just saying that consuming too much folate can actually prevent identification of other nutrient deficiencies. And folate or folic acid sources, you'll see lentils, super high, way higher than anything else on this chart. Also sunflower seeds and peanuts, quite a bit in spaghetti, asparagus, spinach, some in orange juice, so kind of all over the map here, but certainly lentils are the big winner here in terms of folate source. Vitamin B12 or cobalamin. Now, cobalamin you're not going to see on a nutrients label. It will be listed as vitamin B12. And it has really important job for your body. It's important for ATP production from certain fatty acids, amino acid conversion, so conversion of homocysteine to methionine, and maintenance of myelin coating on nerves. And again, you'll remember from when we talked about lipids, we talked about sort of that how myelin is sort of that cushiony protective coating around your nerves that prevents nerve damage to allow the effective um, effective transfer of nerve senses from one nerve cell to the other. Vitamin B12 is also important in amino acid and protein metabolism. The RDA for men and women for vitamin B12 is 2.4 micrograms per day. Sources, it's found naturally only in animal products, but can also be found in some fortified products. Deficiency of vitamin B12 can lead to pernicious anemia, increased homocysteine levels, decreased folate activation, numbness and tingling, gait abnormalities, which is gait is your walking, memory loss, disorientation, and in severe cases, paralysis and death. For vitamin B12, there are no reported effects from intakes up to 100 micrograms per day from either food or supplements. One thing I do want to note here, and you'll notice it as we continue talking about other vitamins, is you'll often see that even though we're talking about one vitamin, there's mention of several other vitamins. So in this case, we talked about decreased folate activation can be seen with a vitamin B12 deficiency. Many of these vitamins work in partnership with one another to carry out reactions in your body. So a deficiency in one of them can affect the ability of others to do their work. So just something to keep in mind as we're going through here, that that your vitamins are all very connected in the work that they do. And vitamin B12 sources, again, like we said, in animal products. You see some B12 in dairy sources, but the real champions here are protein sources like pork, beef, trout, and chicken. Vitamin C. So we just finished talking about all the B vitamins. They're all water soluble. Vitamin C is the other water soluble vitamin. So we're going to finish up with this one, at least for this category. So vitamin C, also called ascorbic acid. You may see ascorbic acid listed on an ingredients label. However, in a nutrition facts label, you will see vitamin C. Functions of vitamin C include synthesis and maintenance of collagen, which is the base of all connective tissue in your body. It's needed for synthesis of neurotransmitters, hormones, bile acids, and carnitine, which is needed for fatty acid breakdown. And if you remember from our amino acid example, vitamin C serves as an antioxidant in blood and body fluids. This allows it to help maintain your immune system. It also regenerates active antioxidant form of vitamin E, and vitamin C works to enhance iron absorption. This figure is showing vitamin C and the production of collagen connective tissue fibers. So you have a collagen molecule, which is this little purple kind of squiggly line here. In the absence of vitamin C, you have all of these collagen molecules that are just kind of doing their own thing, not very strong. If you put any pressure on them, they'll just kind of fall to the side, but in the presence of vitamin C, we get these strong cross links of connective tissue between collagen molecules that allow them to form kind of a stronger sort of a web that allows them to work as structural molecules and structural tissues in your body. The RDA for vitamin C in men is 90 milligrams per day, and in women it is 75 milligrams per day. Sources of vitamin C, probably a lot you're familiar with: citrus fruits, strawberries, kiwis, cantaloupe, cabbage family vegetables and dark green vegetables, green and red peppers, okra, tomatoes, and potatoes. The deficiency for vitamin C is known as scurvy. Probably, if you've heard of scurvy, you've heard of it with regard to pirates or people that spent a lot of time on ships, years and years ago. Because vitamin C is mostly found in fruits and vegetables, you can imagine that somebody who is living on a ship for a long period of time, back when they didn't have good refrigeration or storage, fruits and vegetables just weren't going to stay good on a ship for a long period of time. So, with that being somebody's only source of vitamin C, often they would suffer from a vitamin C deficiency. They would suffer from scurvy because they wouldn't have access to those sources. Scurvy is characterized by gum and tooth problems, joint pain, bleeding, poor wound healing, bone fractures, fatigue, depression, and hysteria. Excess vitamin C supplementation. So I know sometimes people take vitamin C because they think it's going to really boost their immunity and help protect them from sickness and all this other stuff. But excess vitamin C supplementation is actually really not good for you. It can lead to diarrhea, nausea, abdominal cramps, and can possibly increase the formation of kidney stones. In this picture, is a picture of somebody who has scurvy, again showing the tooth and gum problems that can result in somebody with a severe vitamin C deficiency. And sources of vitamin C, we have kiwi and orange juice, which are just through the roof. Strawberries, also super huge. Cantaloupe. Apples have a little bit. And then in the vegetable group, broccoli, spinach, tomatoes, potatoes, all good sources of vitamin C. Choline. Choline is kind of a funny thing. So choline is a water-soluble substance, though it isn't classified as a vitamin. It is included in vitamin B complex supplements. So, they do sell supplements that are, vitamin B complex, and they would have all those B vitamins that we talked about, but it'll also include choline. Choline isn't a true vitamin, though it is often lumped in with B vitamins. It's synthesized to a limited extent by humans and is an essential nutrient, so it is something that you need to consume, though it isn't currently classified as an actual vitamin. Choline is important for the synthesis of the neurotransmitter acetylcholine, structure and function of cell membranes, lipid transport, and homocysteine metabolism. The AI for choline for men is 550 milligrams per day, and for women, 425 milligrams per day. Sources of choline include egg yolks, liver, meat, fish, wheat germ, and nuts. Deficiency during pregnancy can interfere with fetal brain development and cause fatty liver and muscle in adults. Excess choline can lead to a fishy body odor, sweating, reduced growth rate, low blood pressure, and liver damage at levels higher than can be obtained from food. So in this instance, we're talking about choline supplementation. And then I'm just going to go through these really quickly. This is table 7.2 in your text. You really can't read it here, but I wanted to at least point it out because it is in your text, and it gives a really good simplified breakdown of each of the water-soluble vitamins that we just talked about, their sources, recommendations, major functions, deficiencies, toxicities. So this is a good reference for you to kind of look over, and kind of a one-stop shop when it comes to summary of water-soluble vitamins. All right, so that was quite a bit of information, but like I said, you're not responsible for memorizing, those complicated chemical processes or, specific RDA numbers or AI numbers. We're going to move now into talking about fat-soluble vitamins, and we're going to start, I believe, with vitamin A. First, a bit of an introduction. So fat-soluble vitamins, if you remember from the chart we had earlier, the slide we had earlier in this lecture, fat-soluble vitamins include vitamins A, D, E, and K. They are found with fats in foods and require special handling for absorption, transport, and excretion. Excretion limitations increases the risk of toxicity because fat-soluble vitamins are actually stored in your liver and adipose tissue. Intakes can vary without a risk of deficiency if the average intake over weeks or months meets your needs. So with these 4 vitamins, A, D, E, and K, when you consume extra, your body will store that, and if, in a few days or next week you don't consume as much of those fat-soluble vitamins, it's able to draw on those stores. Now, that's a good thing, if you're somebody that maybe your diet varies and you might not get enough of a particular fat-soluble vitamin from day to day. But if you're consuming a lot of fat-soluble vitamins, it's not really a good thing, because since your body's storing it, it's storing that excess day after day after day, and that's when you can see risk of toxicity. So vitamin A, a couple different types, retinoids and carotenoids. Retinoids are chemical forms of preformed vitamin A. You may also hear them referred to as retinol, retinal, or retinoic acid. Carotenoids might be something you've heard of before. These are yellow-orange pigments synthesized by plants and many microorganisms. Some carotenoids are vitamin A precursors that are then converted into retinoids. Examples of carotenoids, or an example of a carotenoid, is beta carotene, probably something you've heard of, probably something you would associate with carrots. It is in carrots, but not just carrots. But beta carotene is a provitamin that, once absorbed, is converted in your body into vitamin A. Vitamin A functions, cell differentiation. Immature cells change in structure and function to become specialized by changing gene expression. So you have a bunch of cells. Different cells are going to do different things, but in order for them to grow and change and become specialized, they're going to need the genes that code for those cells are going to need to be turned on or off, and that's where vitamin A comes in. Vitamin A is also necessary for maintenance of epithelial tissue. Epithelial tissue you might think of as your skin. That's true. Your skin is a very, very large piece of epithelial tissue, but it's not the only one you have. Epithelial tissue also makes up linings of other organs in your body. Vitamin A is part of rhodopsin, which is a visual pigment in your eye. When light strikes rhodopsin, it initiates a series of events that result in a nerve signal being sent to the brain, which allows us to see. This is part of why you'll see on the next slide that deficiencies in vitamin A can severely affect function of your eye. because it is such a necessary part of rhodopsin. Carotenoids may also function as antioxidants, similar to vitamin C that we saw earlier when we talked about water-soluble vitamins. The RDA in men for vitamin A is 900 micrograms per day, and in women it's 700 micrograms per day. Sources include animal products like eggs and dairy. Provitamin A is found in fruits and vegetables, beta carotene in orange, yellow, and dark green vegetables. Excuse me. Deficiency of vitamin A is known as xerophthalmia, which is characterized by night blindness, progressing to permanent blindness. In children, children with vitamin A deficiency may experience abnormal jawbone growth and also increased infections. Excess vitamin A, as we talk about fat-soluble vitamins, you're going to see a lot more issues with excess consumption, and that is, again, because your body does store excess of the fat-soluble vitamins. So excess vitamin A can lead to nausea, vomiting, headache, dizziness, blurred vision, lack of muscle coordination, health defects, liver damage, and bone fractures. Specifically, excess beta carotene can cause hypercarotenemia, which is too much carotenoids in your blood. Sources of vitamin A, beef liver through the roof, carrots also, half a cup of cooked carrots would completely meet the RDA for men and women. Mustard greens have quite a bit, apricots, eggs, milk, cheddar cheese. So several different sources there. Vitamin A deficiency, again, because we just talked about the role that vitamin A plays in your sight. Excuse me. On the left-hand side here, we have epithelial tissue. So again, epithelial tissue, an example would be your skin, but can also just be, the lining of other organs. And in this case, we're talking about the epithelial tissue in your eye. So with a normal vitamin A status, you're going to get this nice mucus layer on top of the epithelial tissue of your eye. And that mucus layer is keeps your eye moist and lubricated, which allows those cells to resist damage and function properly. In the absence of vitamin A, you get the creation of keratin, which is hard and dry. So you won't get that soft, moist, lubricating layer of mucus over your eye. It'll just get really hard and dry and can lead to further damage of the epithelial tissue that makes up your eye and negatively affect your sight. Vitamin A deficiency is something that we see more frequently, or it has higher prevalence in certain areas of the globe. So on this map, you can see higher areas of vitamin A deficiency in Africa, South Asia, Southeastern Asia, South America. One of the strategies that public health officials have used to combat vitamin A deficiency is the development of golden rice. Some of the cultures that experience vitamin A deficiency consume a lot of rice as part of their normal diet. So if they're already consuming a lot of rice, a good public health approach would be to enrich that product with some vitamin A. So a lot of public health scientists did research and found that they could enrich rice products with beta carotene, which would allow populations in countries with vitamin A deficiency to not have to change their diet, but they would then be able to consume proper levels of vitamin A. So the addition of beta carotene to rice is what also led to it being called golden rice, because beta carotene is associated with a yellow-orange plant pigment. Once the beta carotene was added to the rice, it did change its color to more of a golden color. So that's why it's called golden rice. But just a good example of public health strategies and how they intersect with nutrition and can be used to combat deficiencies around the world. And this picture shows vitamin A excess. So the individual on the right is somebody that has excess vitamin A, and you'll notice that they have high levels of carotenoids in their blood, and because of the pigment characteristics of beta carotene, it actually has changed the color of their blood, the color of their skin, a little bit as more of a yellow-orange. So when you see it compared to somebody without excess vitamin A, you can definitely tell that there's a difference. All right, next fat-soluble vitamin we're going to talk about, vitamin D. Vitamin D is made in your skin, but needs exposure to UV light or ultraviolet light. It is inactive until it's modified in your liver and kidneys, and is essential in the diet only when exposure to sunlight is limited or the body's ability to synthesize it is reduced. Vitamin D deficiency is something that is sometimes seen in the more northern parts of the northern hemisphere and more southern parts of the southern hemisphere, where they don't get consistent rates of sunlight throughout the course of the year. So for us here in the winter, obviously, we notice it already that it's getting darker earlier and our exposure to sunlight is starting to be more limited. Also in cultures where it's customary for people to cover up their body, maybe wearing a hijab or headscarves, anything that covers your skin can reduce your body's interaction with UV light and lead to a vitamin D deficiency. Vitamin D functions, maintains normal levels of the minerals calcium and phosphorus in the blood. Excuse me. Calcium is needed for bone health and functioning of nerves, muscles, glands, and other tissues. Low blood calcium stimulates parathyroid hormone or PTH release, which stimulates vitamin D activation. Vitamin D also works to change gene expression. In your intestines, vitamin D actually turns on the genes for calcium absorption. So, if you didn't have enough vitamin D, those genes in your intestines might not be turned on, and you might just simply excrete calcium that you consume without ever being able to absorb it. Also in your bones, it turns on genes for bone breakdown. Vitamin D in your immune system helps you fight infection, helps with muscle function, cardiovascular function for a healthy heart and circulation, promotes healthy lungs and airways as part of your respiratory system, brain development, and also anti-cancer effects. The RDA for vitamin D in adults age 70 and under is 600 IU. IU just stands for international units, and 600 IU equals about 15 micrograms per day. Sources of vitamin D include liver, egg yolks, and oily fish, for example, salmon, also fortified foods. Deficiencies, we're going to see deficiency of vitamin D mostly affecting the bones. So low calcium absorption can lead to rickets in children, which can produce pigeon breast or bowed legs, and also osteomalacia. Excess vitamin D can cause high calcium concentrations in the blood and urine, deposits of calcium in soft tissues such as the blood vessels and kidneys, which can also lead to cardiovascular damage. Vitamin D sources, salmon through the roof. Also, 1% milk and eggs are good sources, but as you can see, not nearly as good as salmon. And this picture is of a child who is suffering from rickets. You'll notice how his legs are misshapen due to a vitamin D deficiency. It makes it difficult for the body to deposit calcium in your bones for growth, leading to abnormal bone growth, which affects the shape and function of those bones. All right, next fat-soluble vitamin, vitamin E. Vitamin E is an antioxidant. It's a very important antioxidant. Protects lipids, including those in membranes of red blood cells, white blood cells, nerve cells, and lung cells. It defends cells against damage caused by heavy metals like lead and mercury, and toxins such as carbon tetrachloride, benzene, and other drugs. As an antioxidant, vitamin E reduces your risk of heart disease, cancer, Alzheimer's disease, macular degeneration, and other chronic diseases. Vitamin E also has possible anti-inflammatory functions, modulation of immunity, regulation of cell growth and death of genes, detoxification of harmful substances. So what are antioxidants? We've talked about vitamin C and we've talked about vitamin E and how they're antioxidants. We had that picture earlier in the chapter showing how vitamin C kind of swoops in and protects your DNA. Let's just talk about it in a little bit more detail because it is really important. Antioxidants are things that you hear about a lot in marketing and discussion of food, but they don't really get into too much detail. So, antioxidants are substances that decrease the adverse effects of free radicals. Okay, fine, but what are free radicals? During aerobic metabolic reactions, oxygen can react with compounds and produce highly unstable molecules called free radicals. A free radical is a molecule with one or more unpaired electrons. Molecules that are considered stable have an even number of electrons. When there's an odd number, that extra electron can cause that molecule to become unstable and damage other cells and DNA in the body. To regain stability, the free radical quickly finds a stable compound from which to steal an electron. Now this compound becomes a free radical itself and steals from another, and so on and so on. So the basics of free radicals kind of work around this electron exchange. And so without pairs of electrons, with just a loose extra electron, it's always looking to find its pair. And in order to find that pair, it steals from other molecules. So the purpose of antioxidants is to neutralize the free radicals by donating one of their electrons. So you have this free radical flying around in your body, looking for extra electrons, willing to take it from wherever it can get it. And then you have antioxidants like vitamin C and vitamin E that come in and say, okay, free radical, calm down. Here you can just have one of my electrons. So the free radical takes the electron and then it is neutralized. And it's no longer banging around into things, breaking up DNA, and it can just be happy and relaxed. When vitamin C and E donate one of their electrons to the free radical, they don't themselves become free radicals because vitamin E and vitamin C are stable whether they have paired electrons or not. Free radicals attack and cause damage to the PUFAs of lipoproteins. DNA and RNA, also proteins. Free radicals can create excesses and deficiencies, impair cell function, and elicit an inflammatory response. Ultimately, free radicals lead to cell damage, disease progression, and aging. And PUFAs, if you don't remember, that abbreviation stands for polyunsaturated fatty acids. So just a little review there. Here's another diagram showing vitamin E and its function as an antioxidant. So you have this lipoprotein bilayer that you remember makes up the membrane of a lot of your cells. And again, you have these free radicals just banging right through this cell membrane, breaking it up, causing damage. And then they get to vitamin E, right? Vitamin E existing here in the cell membrane. And vitamin C says, whoa, calm down. Have one of my electrons, no big deal. And the free radical takes that extra electron and then becomes neutralized. It stops banging around, just, pretty chill, right? And this is a blown up picture of kind of what's happening here, where you have vitamin E giving up its electron, and then vitamin C giving one of its electrons to vitamin E so that it can give it back to the free radical, and so on and so on and so on. So it's really all about this exchange of electrons and how vitamin E and vitamin C as antioxidants are just so generous in giving their electrons to free radicals to prevent further damage to your cells. Vitamin E, the RDA in adults, is 15 milligrams of alpha tocopherol a day. Alpha tocopherol is just a more scientific name type of vitamin E, not anything you're going to have to worry too much about. Sources of vitamin E include seeds, nuts, plant oils, leafy green vegetables, wheat germ, and fortified cereals. Deficiency of vitamin E can lead to hemolytic anemia in infants. Hemolytic means that your blood cells break down, so that's a specific type of anemia. Deficiency of vitamin E is rare in adults, but can cause poor muscle coordination, weakness, and impaired vision. No reported effects from large doses of vitamin E in food. However, excessive supplementation of vitamin E can interfere with blood clotting. Vitamin E sources, we see sunflower seeds and almonds are super, super high. And I don't know if you can see that small, but the serving size that we're talking about here for almonds and sunflower seeds is only a quarter of a cup, which is not that much at all. So only a quarter of a cup will get you more than half of the vitamin E that you need each day. So not too shabby. The last fat-soluble vitamin we're going to talk about is vitamin K. Vitamin K is needed for the production of clotting factors and the synthesis of proteins involved in bone formation and breakdown. Vitamin K can interfere with some medications. So this chart is showing you about the drug warfarin. So warfarin is something that can be prescribed for people that are at really high risk for heart disease and stroke. So warfarin inhibits the formation of active vitamin K so your blood doesn't clot. In somebody that maybe has atherosclerosis or another chronic disease where they have blood vessel constriction, where a clot could lead to a heart attack or a stroke, a doctor may provide warfarin to prevent their blood from clotting and reduce that risk. However, by preventing their blood from clotting, that also means that if they were to cut themselves or have an injury, it would take a lot longer for that wound or that injury to heal, because the warfarin would be preventing their blood from clotting. So for folks that are on warfarin, doctors will recommend low consumption of vitamin K, because the vitamin K is going to work against that warfarin and promote clotting in a person where a doctor feels that clotting could be dangerous. The RDA for vitamin K in men is 120 micrograms per day, and in women it's 90 micrograms per day. Sources include leafy green vegetables, some vegetable oils. Deficiencies of vitamin K include abnormal blood clotting, which can lead to bruising and bleeding, and also reduced bone density, which can lead to fractures. Boy. All right. Excesses of vitamin K, there are no reported effects from food, but large doses can actually interfere with blood clotting. So if somebody is supplementing vitamin K in really large doses, it can actually work against the blood clotting. Sources of vitamin K, look at that, mustard greens. A half a cup of mustard greens is like through the roof for vitamin K. It's the only leafy green listed here, but in general, dark leafy greens are a super source of vitamin K. Also, kiwis, kind of a breakout star here in fruits, giving you about, in 2 medium kiwis, providing you with about 60 micrograms of vitamin K. And similar to water-soluble vitamins, you do have this table in your text. This is table 7.3, giving you a summary of the information that we just talked about vitamins A and D, E, and K. All right, only about 10 more slides. Thanks for hanging in there with me. I know there's a lot of information here, but hopefully you're learning a lot of really great stuff. We're going to talk a little bit now, just to finish out this lecture, talk about meeting vitamin needs with dietary supplements. Supplements contain vitamins and minerals, herbs, and other plant-derived substances and/or body compounds not essential in the diet. They can help people obtain adequate amounts of specific nutrients, but do not provide all the benefits of foods such as fiber, water, and other complementary nutrients. This is in your text. I think it's, for some reason, looking really blurry here. Table 7.4, I'm not going to go through it in great detail, but if you're interested, it does discuss specific population groups that are at higher risk for deficiencies, for whom supplements might be a good idea. So just something you can take a look at. Herbal supplements. The definition of an herb is any non-woody seed-producing plant that dies at the end of the growing season. It also refers to any botanical or plant-derived substance. Just some different things that would be classified as an herbal supplement. I think that's ginkgo biloba right here. I'm not sure what this one is. It's kind of hard to see. This might be ginger, but it's hard to see in the picture. And then garlic and echinacea are some popular herbal supplements. Another table in your text, table 7.5, goes through a list of common herbal supplements, the suggested benefit and use of each of those products, and also side effects that are associated with them. So if you're somebody that takes herbal supplements, I would encourage you to look over table 7.5 to get a little bit more information about the use of that supplement. Supplement regulation. The Dietary Supplement Health and Education Act, DSHEA, of 1994 defined the term dietary supplement and created the first labeling standards. The FDA established current good manufacturing practice regulations, which requires manufacturers to test their products to ensure identity, purity, strength, and composition. The FDA pre-market review is required if an ingredient was not sold in the US before October 15th, 1994. So if an ingredient, if a supplemental ingredient was sold prior to October 15th, 1994, then review isn't necessary before it's put on the market. However, if it's a newer product, then the FDA does need to do a review of that product before it can be marketed for sale. Choosing supplements with care. Try not to exceed 100% of daily values, remembering that some vitamins and minerals can be toxic in high amounts. Consider why it is that you want to take the supplement, and is there another way that you can achieve that without supplementation. Comparing product costs. If it's, a vitamin that you could easily get with a diet modification, it's probably going to be a lot cheaper to just, eat healthy and eat good foods instead of spending a lot of money on supplements. Make sure to read the label, check the expiration date, consider your medical history, and consult a doctor to make sure that there's no interactions with medications that you're currently taking. Approach all herbal supplements with caution and report any harmful effects. And this is an example of a supplemental facts label. In this example, this supplement contains vitamin B6. It contains 400% of your vitamin B6, right? Super. Yeah, maybe not. So does this exceed the UL? Do your research. Make sure it doesn't. And, 400% of a B vitamin, we know that that's water soluble. So extra water soluble vitamins are likely going to be excreted. In addition to the vitamins that the supplement contains, it also contains a bunch of ingredients that aren't vitamins or minerals and therefore have no daily value or UL. The ones in blue are herbs, so they might just be little add-ons to the supplement, but they're in there and they're something that you need to take into consideration and make sure that they're safe. All right. So now that's probably everything and anything you've ever wanted to know about vitamins. I have posted the study guide for your midterm exam in the Dropbox, so feel free to consult that. I'll give you a little bit of a breakdown of the information that you'll need to know. And of course, let me know if you have any questions. Thanks.